Okay, hello everyone. In this video, we are going to be solving different questions, calculation questions, especially that has to do with half-life, that has to do with balancing of nuclear reactions, that has to do with mass defect, nuclear reactions, and all of that. Okay, so here we have the first question. It says a radioactive substance has a half-life of 20 years. What fraction of the original sample will remain after 80 years? Okay, so remember, um, the one of the things that you must know about half-life is what we call the number of half-lives, and the number of half-lives is usually equal to the time all over the half-life itself. Okay, so in this case here, the time is 80 and our half-life is 20. That means we have 4 half-lives. Okay, so 4 half-lives means that the first half-life half, the second half-life, the third, and the fourth. So that's how you find the fraction. Each fraction represents 1 half-life. Half-life is the time it takes for a substance to reduce by half. So the fraction, when you multiply this, we are going to get 1 over 16. So 1 over 16 is the answer. Now, but I want to note something here very quickly. If you are asked to find the amount that remain, the amount that remain is not the same thing as the amount that decay. If you're asked to find the fraction that decay, it has to be, the decay would have to be 1 minus the amount that remain, and that would be 15 over 16. So always when you are reading a question, always be careful to know if you are dealing with decay or remain. Okay, the amount that remain or the amount that decay. Okay, so the second question says a radioactive isotope has a half-life of 15 days. If the initial mass is 80 grams, what mass remains after 15 days? Okay, I think this is quite easy. Let me start by getting the number of half-lives, which is the total time over the half-life. The total time is 15, the half-life is 3, so we have 3 half-lives. So that means in each half-lives, this guy reduces. So we start with 80 gram. The first half-life, that's the mass now, keep reducing. Divide this by 2, that is 40 grams. Divided by 2, that is 20 grams. Divided by 2 again, this is 10 grams. That makes it 3 half-lives. First, second, and third half-life. So the answer here is 10 grams. So B is the answer to this question. Okay, so that leads us to the third one. It says the activity of a radioactive sample drops from 800 becquerel to 100 becquerel in 30 minutes. What is the half-life in this substance? Very simple. Okay, this change happened in 30 minutes. Now let's see the transformation. Let's see how many half-lives will take us from 800 to 100. Now we start with 800. Okay, you divide by 2 is 400. Divide by 2, 200. Divide by 200. You see? So from 800 to 100, you have 3 half-lives. 1, 2, 3. So we have 3 half-lives. Okay? And remember that, well, we can say that these 3 half-lives, the number of half-lives is supposed to be total time over the half-lives. Since we have 3 half-lives, the total time given here all in 30 minutes divided by the half-life. So that means the half-life is going to be 30 divided by 3, which is equal to 10. So the answer is 10 minutes. Another way you can say it is you have 3 half-lives. So the half-lives will just be 30 divided by 3, just what we did here. So 10 minutes, quite easy. Okay, now number 4. A sample originally contains 6.4 times 10 raised to power 24 atoms of a radioactive element. Okay, after 4 half-lives, how many atoms remain? Very easy. So let's see. 6.4 times 10 raised to power 24. The first half-life, divide these amounts by 2. That will be 3.2 times 10 raised to power 24. Divide this by 2 again. That will be 1.6 times 10 raised to power 24. Divide this by 2. This is 1, 2, 3. Okay, divide this by 2. This is going to give us 0.8 times 10 raised to power 24. Then divide this by 2. This is going to be 0.4 times 10 raised to power 24. Okay, which we can write as 4. 0.4 can be written as 4 times 10 raised to power minus 1. Then times 10 raised to power 24. Okay, so minus 1 plus 24, that would be 4 times 10 raised to power 23. That is the answer. Quite easy. So 4 times 10 raised to power 23 atoms. So the answer to this question is C. This is making, a lot of sense. Now the next one is the decay constant lambda for a radioactive nuclide is this. Okay, what is its half-life? Okay, well, half-life has a formula. You can also, there's a relationship between half-life and decay constant. Half-life is 0.693 divided by the decay constant. So that means this is going to be 0.693 divided by 0.0693. This is going to be equal to 10 seconds. So C is the answer to that question. Now number 6 says a patient is given a radiopharmaceutical with a half-life of 6 hours. What percentage of the original activity remains, underline the word remains, after 24 hours? So this is going to be 24 hours and 6 hours represent 3 half-lives. That's because 24 divided by 6, that means 3 half-lives. Okay, remember that half-life is the total time, the number of half-lives is total time over the half-life. So we have 3 half-lives. Now we want to find the percentage. The full percent is 100%, so we keep dividing by 2 until we get to 3 half-lives. So divide by 2 is 50%. We divide by 2 again, that will be 25%. Divide by 2, that will be 12.5%. I think this is where it ends. 1, 2, 3. So we have 1, first, second, third, 3 half-lives. So the answer is C, 12.5%. Very interesting. Okay, so number 7 says a radioactive nuclide decays to 12.0 times 12.5% of its original activity. How many half-lives have elapsed? We just did that. That is 3 half-lives. You start with 100%, which represents complete whole. You divide by 2, that will be 50. Divide by 2, 25. Divide by 2, 12.5. 1, 2, 3. 3 half-lives. Beautiful. Makes a lot of sense. Okay, now for number 8, carbon 14 has a half-life of 5,730 years. Okay, a fossil is found to contain 25% of the original carbon 14 activity. Okay, how old is the fossil? Okay, so that fossil contains this. Wow, 25% of the original. That means that's what remains. Ooh, and now we want to know how old. Well, first of all, we know the number of half-lives. We start with 100%. Okay, that's a whole because we are given in terms of percentage. When you divide that by 2, you get 50%. You divide that by 2, you get 25%. So it means we only have we only have 2 half-lives. Okay, so 2 half-lives simply means that since number of half-lives is equal to the total time over the half-life, so we have 2 half-lives. The total time is what we are looking for here, and the half-life is 5,730. So that means T is going to be 2 times 5,730, and that is going to give us 11,460. This is interesting. This is very interesting. Now number 19. If the decay constant of an isotope is this 1.386 times 10 to the power minus 2 seconds, how long does it take for 75% of the sample to decay. How long does it take for 75% of the sample to decay? Now, notice the word decay. We don't use decay in calculation. So, the complete is 100%. The amount that decay is 75%. That means the amount that remain will be 25%. So, we are interested in 25%. So, we don't use decay for calculations. So, since we want to know the amount that remain, we subtracted 75% from 100%. So that means we need to know how many half-lives from 100% to 25%. So you start with 100%, then that leads to 50% if you divide by 2, then divide by 2 again, 25%, that is 2 half-lives, okay? And first of all, since we are given the decay constant, we can find the half-life, which is 0.693 divided by the decay constant. That means 0.693 divided by 1.386 times 10 to the power minus 2. Okay. And I see this to be equal to 50. I guess so. Yeah, 50. Okay, so am I right? Okay, I think I am correct here. So we have 50 seconds. So now the number of half-lives is the time over the half-life. So the number of half-lives is 2. The time is what we are looking for, and the half-life is 50. Okay, so if you cross multiply, your t is going to be 2 times 50, which is going to be 100 seconds. So interesting. This is very, very, very interesting. Okay, so number 10. Number 10 says a radioactive source has a half-life of 2 years and an initial activity of 400 becquerel. What is the activity after 8 years? We want to know the activity after 8 years. So let's see, how many half-lives do we have in 8 years? That's going to be 8 divided by 2. So we have 4 half-lives. Okay? So that means 4,000 divided by 2 is going to be 2,000. Divided by 2 is 1,000. Divided by 2 is 500. Divided by 2 is 250. That's 1, 2, 3, 4. That's 4 half-lives. So the answer is 250 becquerel. Okay, so thank you very much. We are going to continue this the next session in the next video. Thank you.